Good afternoon, everyone. This is Peter. I'm leading Huawei data storage business. Today, we have entering data intelligence era. In data intelligence era, we have three very important technologies. The first one is large AI models, and then embodied AI and AI for science. All of these are heavily reliant on data and driven by data. The AI big model basically is using the data to understand the physical world and then transferring the physical world to data universe. The embodied AI basically is using the data, using the power of data to reshape the physical world. And then AI for science is using the power of data to explore and to understand the microphysical world. Yes, today we understand the amount of data is really increasing, doubled for every 2 years. And very important, the value of the data also got really increased. Let's take an example on the pathology. For the traditional pathology, the pathologists, they're basically using the microscope to understand whether or not there's disease. The efficiency is really low. But very important thing is we really lack of pathologists. For example, in China, in total, we only have 20,000 pathologists, really not enough for looking after the healthy for the people. But when digitalization comes, we start to use digitalized picture to understand, to check where is the disease, really increase the efficiency of the pathologist to check the samples. 3 times efficiency really got increased. And then when digital intelligence comes, basically people start to use the power of the large modeling to understand the knowledge of each pathologist and then to check the digital image automatically. Therefore, the value of the data really got proved. This is just an example to see on one side, the amount of data increased, but really important, the value of the data also really got increased as well. Today when AI comes, we really understand there's big change and big difference from the AI IT infrastructure to traditional IT infrastructure. Many challenges. The first one is the scaling law, really driving the people to have large scale of the AI infrastructure. The problem is the bottleneck between the GPU or NPU to the storage, which means the bandwidth is really required between the storage and the GPU to make sure we could have really efficient system. On the other hand, is the utility of the whole AI cluster. Today, if you look into most of the AI cluster in this world, most of them, the utility is somehow less than 50%. Even we increase the number of the GPU and NPU, and then the utility even really getting down. That means for such expensive AI cluster, nearly half of the time is just waiting and just a wasting of the energy. At last, the long sequence really becomes common. Particularly, if we really want the machine start to do slow thinking like a human being, the long sequence really becomes the change. But the long sequence for interference will really drive the system more complicated and the cost will be high. These are the challenges need us to do more innovative technologies to keep improving the system. Definitely, storage is a key component for AI data center. For traditional storage, somehow three aspects are mainly considered. The first one is the performance, and then the data paradigm, for example, NAS, objective, etc., and then reliability. When AI comes, we really need to think about more aspects when we design the storage for the AI system. For example, we need ultra performance, really high bandwidth and high IOPS. And also we need data storage to support data fabric. Make sure the owner of the company to understand where is the data asset. And certainly, new data paradigm needed to be supported when AI comes. And certainly, sustainability is really important, energy efficiency, and also scalability. Scalability is not only means scale out to accommodate more capacity for the data, but also the capability for scale up. Therefore, you can support near storage, that kind of computation, to really improve the efficiency of the whole system. And then data resilience start to be more important rather than reliability only. So to have this kind of AI storage this year, by the efforts from Huawei R&D people, we start to announce new generation AI storage, which is OceanStor A-series data storage. Then, what is Huawei OceanStor A-series, particularly A800 storage, looks like me? Let's have a video. Right, this is our new generation OceanStor A-series storage to support AI. For A800, it really got capability to support data fabric. Then to make sure the IT engineer to understand where is the data asset in the whole company. And also, data resilience is supported, particularly it included the ransomware detection, that kind of functionality. And less energy is used. For one unit, it really can accommodate more than 1 TB, that kind of capacity. And also, for each TB, less than 1 watt, that kind of energy really consumed. Certainly, the performance is really high. The total bandwidth is more than 500 gigabytes. And the IOPS can reach 24 million, which is really the highest in the world. And certainly, it really supports the scalability. For scale out, 2048 controllers can be supported. Then more capacity can be smoothly expanded. On the other hand, more DPU can be added, and also NIC, network interface controller, can be added as well to make sure the whole system can have scale up that kind of capability. And new data paradigm certainly is supported. For example, vector, tensor, and also long sequence, that kind of data paradigm will be supported in this one box. This is also the industry first fully symmetric cluster AI storage, which can support more than 100,000 GPU or NPU card per box, per device. The capability is really coming from the fully shared front-end network interface card. In one device, 16 NIC are fully connected. The capability is really aggregated to make sure the total bandwidth can reach 500 gigabytes. That can really allow that kind of one device to connect 192,000 GPU or NPU. And certainly, all the CPU in the controller and all the SSD disks, they are all fully connected to share the bandwidth to improve the efficiency, performance, and also really improve the reliability. Let's take an example. From third-party report, we understand the architecture of the Meta Llama 3, that kind of training system. In total, 240 PB, that kind of capacity is supported to support 48,000 GPU cards. In that system, basically 7,500 servers are used, and also they are being divided into small clusters to act as storage, to have unified naming space, and then 600 servers are also used to manage the metadata. So that's the system. In total, 8,100 servers are used. But if you use OceanStor A800, only 128 devices used to simply support that kind of number of GPU card and also the total capacity. So simple, but very important. The total bandwidth is 1.4 times than the architecture which is used for Meta Llama 3. By using A-serial data storage, we can really improve the efficiency on feeding the data to the GPU or NPU, and also make sure to have really quick checkpoint operation and also recovery operation when some problem happens, which really can improve the utility of the whole AI cluster. Later on, you will see from the report of China Mobile, in their AI cluster, really the number got improved. 32% of the utility got improved by using this kind of new architecture and also innovative technologies. Interference is really important if we really want to make money from AI, because training is just a cost. Long context will definitely become the trend for the future for interference. Because really, we needed to consider multi-source information used for interference, and also multi-round interference will be used as well, which will really increase the complexity and also the cost of the AI system. So we also need some innovative technologies from data storage point of view. In Huawei A-serial data storage, We have the technology called long-term memory, that kind of technology, to support long sequence, long context. Think about it. When people doing thinking, particularly slow thinking, we are not always computing everything. Sometimes we just pick up what we memorized in the brain. So in our storage, we tiering the HBM, which is the level 1 cache, and then together with level 2 cache, which is DDR RAM, and the storage, we regard that as level 3 cache for KV cache. On the other hand, we are not always do computing for prefix. We always stored what we calculated before. So for some operating where we identified has been computed in the before, then we just pick up the results rather than doing computation in the whole system. By doing this kind of architecture, we really can improve the efficiency and also the user experience for interference, which can really improve the user experience, but really important, decrease the cost for each token, which is extremely important, particularly when the AI system really needs slow thinking, that kind of capability. Storage is really driven by the application. In the history, when we have database, we start to have SAN, that kind of storage. When we have internet application, we start to have NAS. When big data comes, we start to have scale-out storage to support Hadoop, Objective, etc. Today, AI will become really the majority application. We definitely believe AI storage really need new technology and also innovation to support that. Therefore, AI storage will become useful and also essential for us to build up AI system to support each industry using the power of the AI to improve the efficiency and to create the value. The AI application is really called for transformative storage for that. We hope by using these AI storage and work together to really empower digital intelligence. Thank you.